In this video, we're going to take a look at molecular elements. So molecular elements are pure substances and they're molecules and they're made up of two or more atoms of the same element. So for example, here we have P4 solid. This is several atoms of the same element connected together. You might also have another example like S8 solid. And so it's several sulfur atoms connected together. And it's called a molecular element because it's two of the same element connected to each other. And specifically, those elements are non-metals. So I should put here, just to specify, non-metal elements. Non-metal elements connected together. And they're connected together by covalent bonds as well, similar to molecular compounds. So a specific type of molecular element that you need to really focus on this year are the diatomic elements, which are molecules made up of two of these same elements, and they are non-metals as well. And so you need to memorize these ones here. These are called the Hofbrinkel elements. They're the diatomic molecules that we memorize in grade 10 and grade 11, and we just use those going forward. And essentially in nature, these elements do not exist alone as individual atoms, but they combine with another one of themselves to be more stable. And so these are the ones that are listed here. We have H2O2, F2, Br2, I2, N2, and Cl2. And we need to remember what these are. So when we name them, H2G is simply hydrogen gas. It is going to be a gas in its standard state at room temperature. O2 is oxygen gas. So in a reaction, when I tell you that something's reacting with oxygen, that is going to be O2 gas, O2G automatically. Fluorine is also a gas at room temperature in its standard state, and it's fluorine gas. Bromine, I made a mistake here. This should not be an S. This should be a liquid. It should be a liquid. So this is bromine, liquid. That's an L, liquid, or liquid bromine. That's the standard state of bromine. Iodine is iodine solid or solid iodine. Nitrogen is nitrogen gas. And then chlorine is chlorine gas. So if you have hydrogen gas, its formula is not H, it's H2, and then you put the state in it, G. Okay, so remember, G stands for gas. The L, so L, when I write it, it's like this, liquid. And the S, solid. So most of your diatomic elements are gases at room temperature with the exception of bromine and iodine. And you can remember that by looking at your periodic table. If you go to your periodic table here and we look at the color coding system, everything that's in red font is essentially a gas at room temperature. And everything that's, for example, blue is is a liquid. And everything that's in black font, like the iodine here, is a solid at room temperature. So these are for your diatomic elements specifically. They need to be paired with each other. So H2O2, F2, Br2, I2, N2, and Cl2. This is not the case for all gases. So for example, if I said neon gas is not diatomic. So just because I put gases means it's diatomic. Neon gas is just neon. So really focus on these ones here as your rules when you're writing your formulas. You can remember it by thinking Brinkelhoff or Hofbrinkel. This is a bit mean, but you could say I have no bright or clever friends. So I for iodine, H for hydrogen, N for nitrogen, Br for bromine, O for oxygen, Cl for chlorine, and F for fluorine. Now, a couple notes I do want to mention. If these elements are in compounds, you need to do the crisscross to determine their subscript. So for example, if I had aluminum chloride, and you think, oh, well, this needs to be AlCl2 because chlorine is always Cl2. No, Chlorine is Cl2 if it's sort of alone in the atmosphere or not in a compound. If it's in a compound, do your crisscross to find out what the subscript is for that chlorine. So be careful with that. Do not make that mistake. Okay. And the same goes for all the other elements up there. And then usually if you're writing a word equation, don't include the state. So for example, if I'm saying that carbon reacts with oxygen, I don't have to put oxygen gas in there. I can just write oxygen to produce carbon dioxide. Scientists will know that this is oxygen gas. So if I were to write this as a skeleton equation, let's just say that's solid here. I need to remember that oxygen, when I'm mentioning oxygen here, it's in its diatomic form, O2 gas. And then we have CO2. So essentially, when you see these, even if there's no state written next to them, you need to assume that we're talking about the diatomic version of them because that's how they exist in nature. Unless I specifically say the oxygen atom or the oxygen ion, we're really talking about how they occur in nature. So you breathe in O2, not the O atom. You breathe in an oxygen gas molecule. And so that there is how we would go about naming the diatomic molecules. Make sure you know them. Make sure you know their states at room temperature as well. And don't make the mistake of thinking that you always have a 2 there. If you're in compounds, you need to use your crisscross.